This is a query processing architecture module, and we will analyze a DML select query in this video. This is a select query. There are two tables involved in the select query, product table and the supplier table, and we will join these two tables by using the inner join, and we'll extract the all the items related to a supplier. We will check how many items for any particular suppliers. So we will check all the suppliers items by using the by grouping the items, and then this query select query we will pass to the optimizer, and we will see what the optimizer will do with this query. A query optimizer is the important part of the SQL Server database engine architecture. This is the SQL Server architecture engine, and this architecture engine has different part, and among these part is the very important part is the optimizer. When the query comes to the optimizer will optimize the query, and it will generate an execution plan. Execution plan is the main plan which will define the steps for the execution of the query. So the query itself, the select query itself does not describe the any steps for the execution. This is a non-procedural query. This query only defines the formats for the this tables and these classes which is defined in this select query, but this query does not define the steps how to extract the data from these tables, what the method will be used for to extract the data from these tables. This is the responsibility of the query optimizer. So when the query will pass to the database engine, the query will go to the optimizer. Optimizer will check the statistics related to this query, and then will optimize the query. After optimization, the query optimizer will choose a suitable plan to execute the query. This plan is the most important uh, thing which generated by the optimizer, generated by this query architecture. What this plan will do, this plan will have some steps. It will define the sequences in which way the data will be extracted from the source table. So we have the two tables, product tables, which is joined with the supplier table. So the execution plan will define how, in which sequence the data will be extracted from the this table. Either will be extracted first from the supplier tables, and then from the matching records from the product tables, or from first from the products table and then the matching records from the supplier tables. These all the sequences will be defined by the execution plan, and the execution plan will also choose a suitable method to extract the data from the tables. There are different methods available for the extraction of the data, and these methods are index scan method. If there is an index on the table and the large amount of the data is extracted from the table, then optimizer may choose an index scan method. And there is an index seek method. If there is only particular values are extracted, then it may choose the this index seek method. And if the table has no index, then the query optimizer may choose the table scan methods to extract the data from the tables. And this execution plan will also have the methods to compute the calculations, like we are counting the colors for each products available related to a particular supplier. So this compute function, group by classes and the order by classes, there are some methods will be used by the query, and this method will be defined by the optimizer in the execution plan. So now these methods may be the aggregate methods. There are different aggregate methods available. So some particular suitable first method will be chosen by the execution plan. And now if we will go to the SQL server, we can execute this query. This is our query. And if we will execute the query, so after executing this query, I have switched on the include the actual execution plan. So we will see what the plan chosen by the optimizer to for this query. So this query has two tables, and there is an inner join between these tables, and the data is extracted by this query, and this is the roadmap for this query. So now the method choose to extract the data from the product table. This is the first is the product table, the sequence that the product table's data will be extracted first, and the method used to extract the data is the cluster index scan. This we can see from these properties also. Physical operation is cluster index scan. And after this because this table has a 500,000 record, it's a large table, and large data is extracted. So this when the large data is extracted and the table is not sorted as per these columns which are used in the group by class, because this table has a index cluster index on the item ID. So records are sorted based on the item IDs, and the second table, which is a supplier table, has no any cluster index. So if the records in this large table is not sorted as per this group by class, which are the column used in the group by class, then to aggregate the data from these columns, there is a function hash match aggregate. This function will be used. This is a very fast function for aggregation, and this function will be used when the data is not in the sorted format, and it will aggregate the data from this table. And now there is the table is the supplier table. On the supplier table, as there is no index, and optimizer is using the table scan method, and now from both these tables the data will be joined by inner join. Inner join is a logical function, and this is the logical operator, and then the two in behind the scene, the hash method will be used to join the data from these tables. So hash join will be used. Hash join, what it will do, it will build a hash table in the memory, and it will divide the equally sized data in the buckets, and these are the buckets are the linked list, and these buckets the data will be joined from both these tables using the hash keys. And hash function is used for to combine this data, and after that the data will be aggregated by using the stream aggregator. There are two aggregate function is used. One is the hash. This is a hash aggregate, and this is a stream aggregate. Both are very fast. Hash aggregate is working best with the unsorted data, but the stream aggregate will work uh, better when the data is sorted. It will work only with the sorted data. So if the data is not sorted, what means sorted? Sorted means the columns which are used in the group by class, if data is not uh, sorted as per this group by class, then this sort method will be applied to for the stream aggregate. Stream aggregate required the data in the sorted format, and if the data is not sorted, then the engine will force to sort the data first, and then it will give to the aggregate function, and the aggregate will aggregate the data. Stream aggregate will aggregate the data. And if we can go in this property of this operator, we can see the data will be aggregated by using this sum. The whatever the data is coming from the previous operator, it will be summed, and then it will be stored in this global this is an expression, global lag 1005, and the expression is stored in this operators. What is doing is stored in this expression. And now there is the next operator will be applied. If you can see, this is applied on this lag 1005 expression, the compute scalar operator is also a very basic operator used in the execution plan, and this operator is used to calculate a new value from the existing row values. These are the data which is existed here. These all operators are used internally by the optimizer. So whatever the data returned by this operator, Now the values returned by this operator to compute a single value from this operator, a compute scalar function will be applied on this. And what are the scalar functions? Scalar functions are the like concatenate, are the convert functions. These are the scalar functions which will applied on the data so that to be passed uh, as per the format to the next operator. So if we will go to the properties of this operator, we can find that we can see here, this is the global lag 1005, which is the expression used in this stream aggregate operator. So now the stream aggregate result is in this expression, and on this expression, when this expression is passed to this compute scalar operator, then this scalar operator will convert the data. This convert is a scalar function. So this function, scalar function, will be applied by this compute scalar operator to compute the values, and then these values will be returned to the client. So this is the select is nothing. And this is the query analysis for when we are passing the select query to the optimizer, what the optimizer is doing with this query, what the steps adopted by this optimizer to optimize the query to generate the execution plan. So this is the analysis of a query.